Okay, so welcome back to another video. So in today's video we have the following limit, that the limit as x approaches 0 of sine of x divided by x to the power 1 divided by 1 minus cosine of x. And then you can clearly see that if you were to plug 0 into your limit, you're going to get that it's a indeterminate form. So basically it's all just about rewriting our expression and applying, L'Hopital's rule, of course, dealing with the indeterminate forms to see if we can actually get some finite value of the limit. So basically that's the gist of how this expression is going to work from here. So let's actually just jump in. So I'll just define capital L as our given limit. So the limit x approaches 0, sine of x, and then x, and then to the power 1 divided by 1 minus cosine of x. So we obviously know that the limit as x approaches 0 of sine of x divided by x, that's going to just equal 1. That's a well-known fact. I've actually proved a little video of this showing the limit is equal to 1 without using L'Hopital's rule, so I'll leave that link in the description. And then another well-known fact is that the limit as x approaches 0 of 1 divided by 1 minus cosine of x, that's actually approaches to infinity. And now using these facts here, we can actually use these facts to actually put it into our given limit here. And then you'll see that if I were to plug everything else here, so that means, so I'll just rewrite this again a second time. So if I just do our substitution with the facts that we have, we know that then that's actually just going to equal to 1 to the power infinity, which of course this is actually an indeterminate form. So let's actually do some manipulation to our equation over here. So let's actually take the natural log of both sides. So I'll take the natural log of capital L, and then when I take the natural log of our limit right here, so that means 1 over 1 minus cosine of x, that goes out to the front of our natural log. So of course this is still the limit, so the limit as x approaches 0. Then that means I'll just write as our numerator that this is actually the natural log, since we're taking the natural log of our sine of x divided by x, and then the exponent goes out to the front, so basically the denominator is just going to be 1 minus cosine of x. And now if you were to plug our your limit for x approaches 0, simply we know that sine of x over x is just 1, so ln of 1 is 0, 1 minus cosine of 0, which is 1, so 1 minus 1 is 0, so you get a 0 over 0 indeterminate form. So what do we do from here when we have this indeterminate form? You can actually apply L'Hopital's rule. So now L'Hopital's rule basically just says that if you have an indeterminate form, it'd be 0 over 0, infinity over infinity, 1 to the power infinity, or even negative infinity divided by negative infinity. Any of those indeterminate forms, you basically just take the derivative of your numerator and then divide by the derivative of your denominator as you take that same limit as it's approaching. So natural log of L, so when we take the derivative, so write this as the limit as x approaches 0. So the limit, so the derivative ln of sine of x, simply, so it's just, this will just be 1 divided by sine of x divided by x. I'll flip the reciprocal, so this is just x divided by sine of x, and then multiply with the derivative of the inside. So this is basically taking our quotient rule. So if you actually just solve this out, we get that this is the x times cosine of x minus sine of x. And then we divide this by x squared, and then you just take the derivative of the bottom over here. So it's negative cosine of x, that's just sine of x. And then keep rewriting further if we want to simplify some things out. So let's see, the limit as x approaches 0. So I can just use this fact that the sine of x on the denominator, I'll just combine this under one fraction. So let's see, we have that the x's cancel, so this is just left with one term of x on the bottom. So we have that the denominator would be x times sine square of x, and then the numerator is just still remain the same, x cosine of x minus sine of x. I want to say the denominator is x times sine square of x. Okay, and now if we were to plug this limit in, so let's see, if I plug 0, so this will be 0, that will be 0, and then over here, so this is still a 0 over 0 indeterminate form. So again, what do you do from here? You can just use L'Hopital's rule again. So now if I take the derivative again using L'Hopital's rule, so the limit as x approaches 0, so that means from here we would actually have to use the product rule. So let's see, x, well, this is just cosine of x, then plus, well, this time this will be minus x sine of x, cosine of x, so minus cosine of x. Okay, and then over here this is taking the denominator, so again you would actually have to use product rule again. So let's see, in the denominator this is sine square of x, and then x, and then we actually use the chain rule for this. So skipping that word, we know that this is very easy to show, so then this will just be 2x sine of x, and then multiply with cosine of x. Well, actually now you can factor out some stuff. Let's see, so we have cosine minus cosine, that is 0, and then you can factor out a sine of x, so the top and bottoms will cancel, so you actually will get a negative x. So first let me write the limit as x approaches 0. Okay, so factor out the sine of x, so that means this will be a sine of x on the bottom, then add this with 2x cosine x, and then in the numerator this will be a negative x. Okay, and now if we plug this again with our x approaches 0, so 0, and then 0, 0. So again, another indeterminate form, 0 over 0, so you do L'Hopital's rule again. So let me just re-establish, so far on the left hand side we still have the natural log of capital X, and then if we take the limit and we have our limit again, so applying L'Hopital's rule again for the third time. So the third time, let's see, we have 1, 2, this is our third time using L'Hopital's rule. So this is actually going to be the end of that, because if you notice that we have a negative x on the numerator, you differentiate that, you get a negative 1. So it will no longer be indeterminate form since we have a constant on the numerator. But let's see what we got for the denominator. So let's see, this will be cosine of x. Okay, and then over here this would have to be okay, so over here you would use the product rule. So this is 2 cosine of x, and then 2x, and then this will be minus 2x sine of x. And if you plug all this in, so that means let's see if I'll plug 0 for everything here. So this is cosine of 0 plus 2 times cosine of 0, and then minus 2 times 0, then sine of 0, and this is negative 1 on the top. Let's see, this is b0, and then this will be 1, then 2 times 1, so that's 3 in the denominator, so we get that as equal to negative 1 over 3. And we have shown that the natural log of L is equal negative 1 over 3, but simply we set that L is equal to our given limit, so we have the natural log of that. Take the e base of both sides, so e to the natural log of L then equals e to the negative 1 over 3, and therefore we have shown that L, our given limit, is equal to e to the power negative 1 over 3, like so. And there we have it. Our following limit is in this black box drawn in. So yeah, that's pretty cool if you ask me.